Good evening. Gotta something. I'm a network guy, so there's something not working, and you blame the firewall. It was me. Who of you guys are in development rather than networking? Good, good. No, that's actually the audience I want to talk to, because at this moment, when I go to customers and I'm talking about Azure, that's how most network admins feel when you talk about Azure. Like, what's this? It's cloud. We cannot touch it. We cannot put it in a rack. We cannot configure anything through Telnet or secure shell, or it's all a web interface and it's Microsoft.
And it's beautiful.
It is. Awesome. So this is actually a tale of the last 3 months where I've been catapulted into the whole Microsoft ecosystem. As you can see, I've not fully adopted yet into the Borg system. Yes, that's true. So it will come. So that's actually where I want to start. It's like, look at it from a network angle. Also a security angle. So the first thing, if you go to a security conference, there's a lot of people talking about zero trust environments. And what is a zero trust environment? Well, you have your users, you have your data, you have your applications. You guys made the applications, users generate that data, put that in your systems, and so on. But where is it? Yeah. Most of the time, your users are surrounded by those data and that applications, and they use that on a daily basis. They interact with that. But then you have this, bad guys, going in and trying to steal that data. You gotta ask Sony, for example. Huh? I don't want to do a scary talk on the internet is bad. I'm going to talk about how can we solve it, or how can we help out. So you find those zero trust environments everywhere. So the whole perimeter, and like make sure that there's a big beefy firewall at the edge of your network, and there's a DMZ, and so on and so on. Is that really still there? Isn't that like a big chunk of Swiss cheese with a lot of holes? Or is it not? I mean, if we look at this chart, we see HQ, we see subsidiaries, we see cloud, we see remote users. Some parts have user data, some have only applications and data, like in the cloud, in the data center. HQ might be mixed environment. Yeah. So where as an attacker do you want to go to? And where as a company do you want to defend yourself? And basically, your attack surface has tripled, quadrupled, because you have a lot more attack surface that you want to cover. So that's the first part on the security, because a lot of network admins, when you think about cloud, they're like, oh, I need to give responsibility away. And most of them, I admit, what I do myself, I do better. Yeah, at least I think that it is. But is that? Might be that if you just give control to a lot of your stack to a provider like Microsoft or whatever, it might help you in doing jobs quicker and more efficient. So the last 3 months I've been at a lot of customers doing installs of our products and our solutions. And you see a lot of different actors within that company. You have the network admin. You have the system guy that normally installs your Windows servers and your Linux servers and whatnot, your AD manager. You also have the security guy in bigger companies that needs to do compliance and check that everything is scanned and secured in any of you guys. Yeah. And what I see a lot is that, and this is an actual case that was in the UK where the network guy, he was managing a checkpoint firewall and his blue code and whatever, all state-of-the-art equipment. But when it came to Azure, he was like, help. Yeah? He even didn't have an Azure account because who managed Azure was the systems guy. And then you had developers, they had developer accounts, but in production, it was that systems guy. So you had 3 different guys sitting on the same level, on the same floor, but so far away from each other, not talking the same language. Yeah? The network guy was like IP addresses, tunnels, VPN, system admin. Hold on. Can you configure that in Active Directory? No. And the SharePoint guy, because this was for a SharePoint setup, developer guy was like, how can I code that in .NET? There's a big problem there. Mainly because in Azure, you cannot translate this. This is a typical deployment of a web service on-premise. And what does the network guy want to do? He wants to put firewalls everywhere. Yeah? He wants to make sure that if it comes from the internet, it goes to a firewall. So he can open up ports and he can do IDS, IPS on it. So intrusion prevention and detection. And then it goes to that front end. And then there's another firewall. Make sure that there's containment toward the app layer. If there is at all an app layer anymore, because it could be that those two are merged if you're talking about REST APIs and so on. And then your database in the backend, which is like the holy grail. Although, yeah, in Sonny's case, for example, it was the fact that there was BitTorrent running on their internal network. And then you have your internal VLAN where you have your typical Active Directory and stuff. So can we translate this or parts of it into Azure? What are the options? So the other thing is, why does that network guy want to do that? Well, you could say, well, he's used to that. That's fine. But there are reasons why guys years ago started with a 3-tier architecture and wanted to make sure that every tier had its function. So first of all, containment. If you hack that web server, then it will get a lot harder to get to the next layer and to the next layer. Yeah? So containment is first one. Logging, make sure that on every step you have separate logging. Inspection of the traffic, because it comes in, but what is that traffic doing? It might be malicious, it might not be. Yeah? You open up that port, but then you can do, for example, IDS, IPS, or you can do a web application firewall and so on. Compliance, a bit less in Europe, a lot more in US, where you need to be compliant with regulation XYZ, which says you need to have firewalls in place. And scalability, to make it more elastic. Now, scalability is one of the things that Azure is good at. So maybe there is a chance we can move that along. So Azure Networking. So we know what we can do on-premise. Now let's try to translate, or at least give you some sense of what Azure is doing and where it is different, and what you can tell your network admin if you're in the case of deploying something. I got a little exercise. This is on a Windows server in Azure. This is one from a server on-premise. What is the difference? Well, as a network admin, you only need to see this. and you're like, yes, I got it. But I see a lot of guys are like, what the hell are you talking about? And this is actually what I want you guys to show to your network admins, if they don't believe that networking on Azure is different. Because yesterday I was talking with a company that's big in firewalls and you name it, and they want to go into Azure and do a lot of stuff in Azure. They even made a big acquisition in the Netherlands, and they're like, I don't get it. What's different in Azure? Well, what is different? Anybody knows the answer? Sorry? Which last bit? Sorry? What is different? No. 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 You see, this is actually a good exercise for you guys on networking. No, the subnet, actually the subnet doesn't matter. It's something else. It's very obvious. And actually, sorry? Yes, that's correct. It's the MAC address. Yeah. This is actually what I wanted you guys to get. If you show this to a network admin, and it's a good network admin, he'll be like, hold on, that's not possible. How can that multiple IP addresses have the same freaking MAC address, and besides the MAC address is 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C. What is going on here? Yeah, what is going on here? This is normal. Yeah, these two are the same because it's the same host, but then 10 has a totally different MAC address. Yeah, 255. Yeah, that's broadcast. Yeah? Those should all be different. Every one of your phones has a different MAC address. On Azure, it's all the same. The first thing I saw is like, hold on, this can't be right. So that's the first thing you need to take into account. And that's your warning sign to your network admin, like, hey, guys, it's networking, it talks IP, but it's a little bit different. Yeah? So a lot of people think that VNETs, which you guys are used to, and you can figure that, and it's all just next, and you have your subnets within a VNet, and then that networking guy says, oh, is that the same as a VLAN or a LAN? It's like, no, not really. Because VNets, and this is taken from the Microsoft documentation, yeah, is actually a layer 3 overlay. So maybe you remember back in the day, OSI layer 3. VLAN is layer 2. Big difference. Because on the layer 3, they can do whatever they want with those MAC addresses. You don't have to care about it. You're not on that layer. You have given control to Microsoft of that layer 2. Yeah? And so that's the crucial difference, because that makes networking a tad different. Yeah? The other thing that I noticed was a lot of guys are firewall admins that said, oh, well, let me ping. The first thing you do, troubleshooting and networking. Or let me do a traceroute. First of all, traceroute doesn't work. Ping, yes, within the same subnet, within the same VNet, it will work. But don't try to ping from the outside to the inside. It doesn't work. Don't try from VNet to ping. It doesn't work. Oh, bummer. So your main networking stuff that you're used to as a network admin, they don't work. So what do you want to do then? Telnet, port 3389, for example, or remote desktop, because Telnet is most of the time not allowed unless you like enable that. But take that into account. Also, your network admin needs to take that into account. because he wants to set up that VPN tunnel, for example, but how does it work? Yeah. So these are the main differences. Another thing that we want to do is connectivity. Make sure that you can connect your company on-premise networks to your Azure Cloud. Because you want to move, for example, your SharePoint or your services into an Azure Cloud because you don't want the service anymore on site. That's all cool. But how do you get there? You can just open it up for the whole internet. It's cool, but maybe some of that data you don't want to show directly to everybody. Maybe you want to contain that. So what is possible there? How can you connect also between subnets? How can you connect between VNETs? And last one, VNET to on-premise. How can you solve that? Yeah? So this is what actually at this moment is possible, yeah? Based on the latest releases in, at TechEd. So I had to take those into account because there were quite some changes. So within subnets, and if I go back a few slides, this one. So if you want to translate this, you want to have a front-end LAN, VNet, whatever, container. You want to have a app VLAN or database VLAN. So let's say 2 or 3 different networks. So in that case, you want to have a virtual network, and within there, subnets. But by default, if we're talking about subnet to subnet, we can say default no ACLs. We can do network security groups, or we can do something with multi-NIC. So no ACLs. It's just everything's allowed in between those subnets. Basically, the question then is, why would you put it in different subnets in the first place? Yeah? But it's a default behavior. TCP, UDP, and ICMP are allowed, so you can ping between those hosts. That's already cool, but that's it. So there's no containment, no logging, so you don't know what is going on between your web server and your database, for example. It's there. It works. It's connected. Yay, it works. There's no inspection of the traffic. Okay, it will work. But security-wise and networking-wise, you might want to do a bit more. So first step, released by Microsoft during TechEd, is network security groups. Network security groups allow you through PowerShell to add some kind of ACLs. There are some limitations, 100, 200 rules, for example, 100 network security groups per subscription. There's no GUI to it. It is also limited to the region, so you cannot like copy that to another region. And you can do it on the VM itself or on the subnet. So you could say this server has those network security rules to get into the server. It's a good thing to do, certainly as a basis. The main problem is we've done some tests on it, and it takes a while to get that network security group applied, like a minute. If you want to contain everything and like shut everything down, a minute is long. Yeah, so it's good. It's the first step, also from Microsoft, to add more of that security in there. The big questions were logging, because you cannot see what is allowed, what is not allowed. You don't have any debugging. So it's there, you put it in there, and then you hope for the best. Does it work? Do you have a connection? Oh, yay. Not? Yeah, okay, let's try it again. So new PowerShell, try again. So that's in between subnets. So feedback we got from also from Azure blogs is like good, but what about drop packets or allowed packets? We cannot see anything. So that's where we worked on getting multi-NIC running, which is another feature that was launched that they hit. And so what we can do is put a firewall with 2 NICs, for example, within the network, get traffic redirected through a client from this front-end VM to the NG firewall, and then get it over to the second NIC. Good thing is, you get visibility, you get the logging, and you get the management. Yeah. So that's one of the possibilities to get more visibility in there. Now, there again, it depends on your project. Yeah? Some customers might say, oh, don't care. Well, it's fine. But we're looking at what are the possibilities here. Yeah? The other disadvantage with multi-NIC, you need bigger instances. It's only A3, A4, and then some of the D series that have 2 or 4 NICs, which is okay, but it can become quite expensive as well. Good. So that's within the same VNet. What if we want to say, well, I have some stuff in Europe, I have some stuff in US. How can I connect and talk between those 2 services? You might want to replicate data. Do you want to just do that plain text over the internet? Cool. I mean, the NSA would love that. It saves them a few cycles. But on the other hand, might better be encrypting that data. So there we have 2 options: IPsec site-to-site and TNAP. I'll go into detail what both are. So no worries. IPsec, default way to build out a tunnel between 2 networks, industry standard, supported by Microsoft, so you can build out between 2 VNets, you can build out a site-to-site tunnel. Make sure that your configuration is on the same, on both sides, has the same configuration variables regarding encryption, regarding perfect forward secrecy, and so on and so on. So all of the different bits and pieces need to be in place. Once that's done, and there's a very nice how-to guide for that on MSDN that will show you step by step how to create that tunnel. Yeah? It's built in, it's fine, it's there. The second thing that at Barracuda we've done is we have a protocol called TINA. Now, TINA is, instead of IPsec based, is SSL based. So it's also encrypted, but it runs over a lot more different ways. What I mean, it runs over TCP UDP, it runs over ESP, which is the default for IPsec. Now remember, if you go back to one of our first slides, Azure only supports TCP and UDP. So the good thing is, we can get TINA to pass through the Azure load balancer, onto the internet, to the other side, wherever. So what we can do between 2 VNets is create that TINA tunnel. Good thing about that is that we can do visibility, can do the logging, and we have more control over what is going on. So that's the 3 ways of building a VNet to VNet configuration. Third part, how do we get from a VNet, from a virtual network, to our on-premise? How can we get our users to connect to that virtual network to do their to connect to their web services, to their database, or whatever service that is offered within that VNet? First one, point-to-site, just one client connected into the VNet, and you're done. If you don't have a lot of users, it doesn't take that many steps to configure it. So if you have 5 users that need to connect to the Azure VNET, this might work. Of course, it means that every one of those users need a certificate and so on. Second one is, again, to create a site-to-site IPsec tunnel. There are some limitations there. We'll go about that as well. Third one is ExpressRoute, which is a, for network guys, MPLS type of connection. And then the fourth possibility is TNet. So if there's any questions, by the way, because I might be talking totally gibberish for you guys, let me know. I mean, I hope I explain every one of the acronyms and so on, but if there's anything, raise your hand or whatever, just speak up. I don't want to like go on bumbling about all of this stuff. So, point to site, it's just built in. You have a client, you just click next, 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 configure it within your Windows system. And good thing is strong authentication, so it's through a client certificate. So like that, the only thing is you need to do that on every client that you want to have connectivity to. So it's good for a few users, for 10 users, 100 users that are not very computer literate. I wouldn't recommend this. Second way, site-to-site VPN tunnel. Yeah. So there again, we go. You have the normal way of setting up a IPsec tunnel. Yeah. There are different tunnels that you can set up, and it's based on which gateway you're using. So first one is a static routing VPN gateway. It only supports one tunnel. So if you have multiple premises, not the best way to go. So Microsoft extended that into 10 or 30. Okay. So there you can set up a site-to-site IPsec encrypted tunnel. Okay. Stuff that some bigger organizations would like to have, like BGP, because they have a very dynamic network. That's not supported. So BGP is a routing protocol, and it basically will say, for example, if an office, then automatically through BGP we can propagate the routes to a different office and say, well, it needs to go now through B instead of directly from C to A, for example. So definitely in bigger organizations, you'll see this being used. Smaller, you don't see it, because most of the time it's 1 or 2 guys that do that on Cisco routers and stuff like that. But in some, it is a necessity. Yeah? So that's something you need to take into account. Another thing that's not in there is the throughput. So there's also throughput limitations there. Standard, this one is 80 megabit. This one goes up to, I think, 200 megabit. And this one can, I think, go beyond that. So that's something also to take into account, certainly if we're talking about high volumes, copying a database, for example, or replicating a database. Then it might be that you run into problems because you think, hey, there's bandwidth enough at Microsoft as long as we pay. Yeah, but not on that tunnel. So take that into account as well. A more advanced, how should I put it, something that a lot of enterprises have is a virtual private network, as in a MPLS connectivity. Some providers like Barracuda call it, forgot the name. Explore, Barracuda Explore. Somebody heard of that? Well, that's basically an MPLS network. So it's not an internet connection. It uses internet technology like ADSL and sometimes cable or whatever, or fiber, to get connectivity. But basically, it's a private network within that operator. They charge you most of the time an arm and a leg for it. Unfortunately, But with that, we can also connect through what Microsoft calls ExpressRoute into the Azure Cloud. Yeah. There are two flavors for ExpressRoute. First one is, I don't get the naming why they put it like that, but somebody might be able to explain that to me someday. But Exchange Provider means that you have, from your office, one dedicated connection through your partner into, sorry, the other way around. So customer side, you go to the ExpressRoute partner location. And so, for example, in Europe, we have Equinix, we have BT, we have Telecity Group, and some others that are interconnected to Azure. So that means customer side to that partner, and then into Azure to get your connectivity. It's one side. Now, most customers that are looking at these types of solutions have multiple sites. Bigger organizations have their own MPLS type of network next to breakouts for internet. So this is not an option for them. They need to go for the second one, more expensive one. Okay? So within the one, you actually just connect a new branch, which is Azure. And it's all reachable through that network. I like this one. Take into account, this one can go up to 10 gig throughput. This one up to 1 gig throughput. Now, most applications should be enough. What else? Pricing. There are a few pricings that you need to take into account if you're looking at ExpressRoute. First one is Azure itself. It charges you for data that you transfer. Not on inbound. Some outbound traffic is free, but then extra after a certain tier, you start to pay. Then that partner needs to be paid as well. So that's where it comes in. First of all, you need to have that connection to Azure. Okay? Some partners, for example, and that might be a trick in getting a less expensive type of solution, is to say, well, getting from ExpressRoute, from the partner location to Azure, that's not expensive. I was talking with one of the partners of Microsoft, and they said 500 euros a month for a basic with some bandwidth, it's doable. I mean, and then here you could say, okay, let's put a firewall here, and then again break out. That could be an option. Otherwise, this scenario, start thinking about 6,000 euros a month. This one, 20,000 a month. So it's there, but that's at least prices from one partner that I got. Yeah. Yeah. Okay. Okay. Sure. Sure. Okay, thank you. Okay. There we go. So, good. Thank you for the feedback. I'm learning as I go. So, last option. Again, Tina. Bit of an insight. One of the protocols within IPsec is called IKE. So, some developer was being funny and said, "Oh, let's call it Tina." So. I don't know. Don't start doing anything. So basically, what we can do with Tina is do the same as the VNET to VNET. Get a firewall in here, direct traffic into that firewall through a client, and then go up to the internet again. Good things are there's no limitation on the number of sites. We can go beyond the 500,000, you name it. We add compression. We had so we make a compression of all the data. One optimization, so we can do byte caching, for example. So we can build up on both sides a dictionary of what we've transferred through the line. If you've already transferred it, like an Excel file or some data stream, you can say, oh, we've already transferred that. Like, let's only transfer a hash instead. Optimizes the data, optimizes latency. Also failover. So included, we can have multiple units, and we can also build up that tunnel to multiple providers on the outside. So that means we can fail over between Belgacom, for example, and Telenet, just to name two. Yeah? And automatically fail over between those. So if you look at the whole slide, what we could do is say, oh, get Tina and get a firewall on-premise and get some in the Azure data center and get all of that connected in between, yeah? And then managed through a control center. Yeah. Good. Now, yes?
I'm just wondering, you're talking about the hybrid, something on-premise, something cloud.
Yeah.
ADFS, how is that exactly working? Is that one of these protocols? Is that a layer on top, or is it something you want to
So ADFS or any of the services that you might deploy runs through that tunnel. So whether you have ADFS running on-premise and you want to make sure that your servers that are within the VNET in Azure need to connect to that ADFS, you can get that through that tunnel. Yes. Yeah. So it's encapsulated within that tunnel. It's the same as an IPsec tunnel. So think about if you know what an IPsec tunnel does, it just puts a packet in there and transmits it to the other side. Same thing for this. So basically, it doesn't extend the network, so it's not the same subnet on both sides, but it's like you connect through a router to networks, but then over a much larger distance. Okay. Any other questions at this moment? Otherwise, I'll hope that my demo works, which is always a bit scary, but we'll see. Good. So what I have is quite simple. I'm not what I have is a basic Windows server within Azure, and I have a firewall connected in between as well. Oh, this is the firewall. This is the console of it. I have for network admins might be very intuitive and like, oh yeah, sure, this is a firewall. I mean, it has rules. It says source destination. Where can I go to? What are the applications through it? Yeah. So this server is actually, instead of talking to the default gateway of Azure, so the default gateway where your traffic normally goes to, we're not talking anymore to that. We're actually getting all the traffic automatically to the firewall. We're doing that through a client that is automatically on all the time. Yeah? There's no connection. You will retry again and again. The firewall itself is an image, an instance that you run within Azure. So if we're looking at Azure itself, Then what we have as virtual machines is this one. Whoa, oh, clicking on it. So we have this one. This is just our instance of that firewall running here. And this is just a Windows server behind it. They're both in the same VNet, same subnet. And normally they wouldn't be able to do anything in between each other, besides talking to each other, but not go through that firewall outbound. Yeah. And so what we're now going to do is, what I've set up is that Windows server goes through that firewall outbound and does whatever he thinks he needs to do. The other way around as well. So we could say, oh, this Windows server has a public IP, so I could define an endpoint and say, oh, get to that web server. What we're going to do now is say, well, instead of going to that endpoint on that web server, first go to the firewall, where I can say yes, allowed or not, and then it redirects it to the server itself. Sure.
I'm saying that the outgoing traffic of VN002 always goes through the firewall before it can go.
Yes.
And how is that enforced internally?
No, currently we're using a VPN client, a client on the Windows server, and that is
Directly going to the internet, or is a VPN client?
VPN client encapsulates all the traffic. So you can try, but it won't work. We could fall back on the normal behavior, or we could say, well, then block all the traffic. Because there's a firewall within that says, okay, block it. And then it doesn't go out either. For now. Yeah. I'd love to change the default gateway in Azure, but currently that's not available. We tried that, but that didn't work out. At least for now. We're still continuing to try that if that works, but for now it's the client that you need to use to get that out. So I've just configured that inbound. I have a website running on port 80, just a default thing, and outbound I said that as it comes through the VPN client, everything's allowed to the internet. But I want to make sure that I'm monitoring all of that. So let me go to the firewall, to the live sessions. Let me start up a session, go to Microsoft, for example. So there we have system. You can already see that there's traffic going through. And so you see automatically these are all the websites that Microsoft's been using, or URLs that they've been using. Yeah. So I could now say, oh, this server cannot go outside, and then he won't be able to serve, for example. Okay. But this way we have full logging of what that server is doing outbound, which might be interesting to know, because if your server is hacked, you actually want to know what that hacker is doing outbound with it, or to another subnet. And that's how you can contain it or log it. So that's the first part. The other way around, here I have GVH AZ001, which is the firewall actually, or the firewall IP. I've allowed port 80 onto it. And so if I allow that, I get to the default IIS page. Sorry, I used to be a developer, but wrong set of languages, so I still need to brush up my .NET skills. But as you can see here, there's traffic coming from, this is the IP address here, from the Wi-Fi. It indicates from, hey, this is Azure, and it's going to this server, and that's the URL we've used. You see? And so the next thing we can do is also say, well, let's change the bandwidth, for example. Let's make sure that we have different types of bandwidths being used. And maybe you can prioritize stuff, or only allows antivirus updates from McAfee, for example, and all the rest you want to block outbound. So it's not only on port, it's also an application. Which type of application can go out based on this? So inbound, outbound, we can control that through that NG firewall. And then set up tunnels to wherever we want. Give you an example. In Germany, if you go to a bank contact, Mr. Cash from Postbank, and you retrieve some money, it's actually an NG firewall in there from Barracuda. So all of those ATMs, they're managed by a control center, around 4,000. So these guys can actually manage from one system and change root passwords, policies, whatnot from one control center. So also their scalability is not a problem. The main thing is getting insight in what is going on. Because if Sony or whatever, I mean, the question nowadays is not anymore, will I be hacked? No, the question is, when will I be hacked? When will I be breached? When will there be a hacker getting into my network? That's when you want to see what is going on. Also, why I like the presentation about the search. You used it for finding a restaurant. I want to use that to search these logs, find what is the behavior that's irregular, that is not part of the normal traffic, and find guys that are doing stuff based on that. So also there we could use Azure again. Sure. Uh-huh. We have different models, so we can go up to, I think, 7 or 8 gigabits of throughput for one system. Now we can even add more if needed. You could do that with a separate control center. You could do that, yes.
What is the effect on the latency? Because for example, you say that how does it affect
for the end user, you won't see that much latency. Certainly if they're going over that TNAT tunnel, we're doing those optimizations, which means that you counteract that encryption, for example. So that makes it pretty performant as well.
Use the Azure load balancer. So activate it on the internal side. For example, you set port 80, so port it to the firewall, but then you no longer have the load balancer for your web phone, for example.
Yeah.
Still the configured in the firewall as well?
Well, we're talking here about networking. If you want to defend like a website, then I would talk to you about a web application firewall, which works in conjunction with your Azure load balancer to really defend that website. And then you can also do the load balancing. Now there's basic load balancing in here. So I could say, well, instead of one server, there's multiple in there. And then do a round robin. So that's inside this system. But as we're talking about networking, if we're talking about web services and defending those web services, then we're talking about WAF and that system. The client can do load balancing as well. So what we can do, I have my colleague actually set up 2 systems in high availability. And based on which one is available, the client will automatically fail over between those 2. So that is also possible. Because this client actually, you can use that one as well when you're outside and you want to connect into Azure, and we can actually do a probe that says which is the nearest one. So all of that is built in actually, and we start it up automatically.
Does the client update itself? The running thing in the VM is updating itself, or not, or
updating in firmware, software update.
Yeah, software update.
Software can be deployed through a GPO or whatever management system that you have in place to push that out. So there's MSIs available. All of the config can also be pushed, or we can push even more through the control center. So we can have a personal firewall that is managed by that control center from Barracuda. So that is possible as well. And then you have your whole stack, so your clients, your servers, your firewalls, all on the networking side, you all manage that through one control center. Other questions? Are there things you'd like to see, or don't ask me to do a handstand, I won't do that, but on the Barracuda stuff? Sorry? If not, with that, small conclusion. So, first of all, talk with all the people that are involved in the project, and be aware that although they're all talking IT, they're not talking the same lingo. Yeah. When I first stepped into a Microsoft office, they were talking like, what's a TSP and a CSA, and I needed like a dictionary. Oh.
I knew I was going to say that.
No, it's normal. It's normal. Every environment has its own. Even within every company, you have your own lingo, and also within functions, you have different languages that you speak. Yeah, you guys speak about functions and about agile development and so on. A network guy doesn't. He speaks about IP addresses and about UDP, TCP, and so on and so on. So make sure that you're on the same level and that you know what you're talking about. Try out the different scenarios for your organization, for your projects, and look at what the goals are. It might be that everything that I've been talking about Barracuda doesn't apply to your company. That's fine. There's plenty of other stuff already out there. Yeah, there's stuff that Microsoft provides that's good enough, or even very good for your project. Yeah? But I wanted to give you an overview of what is currently possible. Yeah, and look at requirements that are not always visible, but connectivity, your visibility on your traffic, and resilience. What in case something fails? Yeah? What do you do then? Make sure that you're one step ahead of that. And with that, I'd like to thank you all for attending and listening to me